Welcome back. So in this video we're going to look at simplifying negative exponents, and we're just going to use the problems we've already done, and we're going to actually do a challenge factoring with rational exponents, and we're going to simplify one of the problems here that I did not simplify, and that's going to be the very first thing we do. So a little reminder, always take a good look when you factor out a greatest common factor to see if what's left is factorable. This is factorable. Right? This is a difference of squares. Right? So we have x to the 1/2. Factoring a difference of squares would just be square root plus square root minus square root. So 1 plus square root of 1 is 1, square root of x squared is x, times 1 minus x. There we go. Now that's done. Now that one looks good. Now the second one there has a negative exponent, and we usually like to simplify negative exponents. That means any term with a negative exponent needs to flip the side that they're on. So if they're in the numerator, they need to go to the denominator. If they have a negative exponent in the denominator, they need to go back to the numerator. All right, so it's super easy to simplify this because it's just a product of factors. The only term with a positive exponent, it's raised to the first power, stays in the numerator. All the terms with negative exponents go to the denominator, and we switch the sign of the exponent from negative to positive. So now this would be x to the 1/2 times x plus 3 to the 1/2. Right? And it's fine to leave it like that. If you want to make it, you could change it. This is fine. You could change it to a radical if you want and make it 2x plus 3 times the square root of x times the square root of x plus 3. But if you're going to do that, you may as well just, you can multiply radicals if they have the same index. So if you're going to do that, you may as well simplify that further and distribute that square root of x and make it 2x plus 3 times the square root of x squared plus 3. All of these are absolutely identical, and all of them are fine. All right? Any one of these. You do not have to worry about rationalizing exponents very much. It's not a very important thing. All right? It's fine to have radicals in the denominator. No one's going to care. All right? But we usually like to simplify the negative exponents. Just makes things a lot simpler to work with than having a negative exponent. So here, super simple. Let's leave the x plus 5 in the numerator and the x plus 3 in the numerator because they have a positive exponent, and move the x to the negative 1/2 to the denominator and change the sign to positive. And if you don't like the exponent of 1/2, you could make that a radical, and that's fine as well. So super easy to simplify the negative exponents. When it's all factored, they just go to the denominator. But make sure the expression is factored. Right? If you're adding and subtracting terms, they can't just willy-nilly decide to leave to the denominator. Right? It has to be factors. Factors can be simplified. Right? So here we have 3 factors. The one with the negative exponent can go to the denominator. Right? And if you don't like it with a fractional exponent, sometimes it's easier when you're simplifying not to have the fractional exponent. If this is the end of our problem, it really doesn't make a difference, does it? But you could also change that. X to the 3/2 is the square root of x cubed. Right? That might make it easier if we were solving it. Right? But in terms of rewriting it, either is fine. I think that might be the last negative exponent, but I wanted to show you, I think so, one more problem. I thought I would do one like this because it is just a tad different than the other substitution ones, because not only is this substitution, this is going to be factored by grouping with 3 terms. And you might not figure out right away that it would be a substitution problem But notice that the denominators are the same, and that the exponents. But the numerators, we got a numerator of 1, 2, 3. So we could call w equal to x to the 1/7. And if we square the w, that would be x to the 1/7 squared. 1/7 times 2 is 2/7. And that means w cubed would be x to the 1/7 cubed, and 1/7 times 3 is 3/7. So now this would be 2w cubed plus w squared plus 4w plus 2, and now this becomes something really easy to factor. Right? So that's the beauty of substitution. It makes things easier to factor. So the first two are a group, second two are a group. Greatest common factor would be the w squared, so we'd have 2w plus 1. Greatest common factor for the second pair would be 2, and again we'd have 2w plus 1. Right? And then we could factor out the repeating 2w plus 1, leave the w squared plus 2. Right? And now the only thing we have left to do is substitute back, because you put the w's in, they weren't there to begin with. So 2 times x to the 1/7 plus 1. And by the way, the w squared plus 2 can't be factored. And let's replace the w squared with x. I put x in there, right? X to the 2/7 plus 2. And there we go. Right? So that would have been hard to factor, right? Without substitution. Substitution makes it really easy, and then we just substitute back. All right, so that's all. I just wanted to show you a few more. And I think that's pretty good for a good review on factoring. Thanks for watching. Bye for now.